In this lecture video we are discussing about bond fission in organic chemistry. And in organic chemistry there are two type of bond fission, one homolytic bond fission and another heterolytic bond fission. And here at first try to understand what is covalent bond, because in organic compound there is always covalent bond, and bond fission in organic chemistry takes place in covalent bond. Therefore now come to here, we have here HCl molecule, then here in between hydrogen and chlorine there is covalent bond, and in the valence shell of chlorine there is 7 electron. This is group 7 elements, this is halogen, and here hydrogen contain 1 electron in its valence shell. And what is covalent bond? When in between the atom, if one pair of electron is shared in between the atom, this is called covalent bond. And here hydrogen give 1 electron and chlorine give 1 electron, and this pair of electron, 1 electron from hydrogen and 1 electron from chlorine, is shared in between the HCl molecule, that is in between hydrogen and chlorine. And when two atoms shared 1 pair electron in between the atom, this is called covalent bond or one covalent bond. Okay, this is covalent bond, and in all organic compound there is covalent bond. And in organic chemistry there is two type of bond fission, one homolytic bond fission and another heterolytic bond fission. And suppose when we take here HCl molecule, and in between this HCl molecule there is 1 pair electron, and this 1 electron is obtained from hydrogen atom. Now see here, and again this another electron is obtained from chlorine. And what is homolytic bond fission? When this shared pair electron, 1 electron shift towards hydrogen and another electron shift towards chlorine, in the cleavage of bond in between hydrogen and chlorine, this is called homolytic bond fission. And in homolytic bond fission, here this shared pair electron, 1 electron comes from hydrogen and 1 electron comes from chlorine atom, and here hydrogen chlorine are neutral atom. And when this bond in between hydrogen chlorine is break down, and if 1 electron shift towards hydrogen and another towards chlorine, or simply when this shared pair electron is gained by this combining atom, 1 electron to the one atom and another electron to the another atom, and there is formation of free radical. And here in homolytic fission there is charge is not developed, and neutral chemical species is obtained. And now see here what is free radical. Here hydrogen, this is free radical, chlorine free radical, and free radical are chargeless species without positive negative charge. Neutral chemical species having odd number of electron in its valence shell. Here in valence shell hydrogen contain 1 electron chargeless, and this is called hydrogen free radical. And here chlorine contain 1, 2, 3, 4, 5, 6, 7 odd number of electron 7, and it is also neutral, this therefore this is free radical. And always in homolytic fission there is formation of free radical. But now come to what is heterolytic bond fission. If this shared pair electron in between the atom shift towards only one atom in the cleavage of covalent bond, this is called heterolytic bond fission. Here these two electron, 1 electron shift to one atom, another electron shift to another atom, this is homolytic bond fission. But if this both shared pair electron shift towards only one atom, this is heterolytic bond fission. And here this shared pair electron shift towards that atom which have higher electronegativity value, and here chlorine electronegativity value 3, hydrogen 2.1, and here which one have greater electronegativity? Chlorine atom. Therefore this shared pair electron if shift towards only one atom, more electronegative atom, this is heterolytic bond fission. And in the heterolytic bond fission there is always formation of ion and ion are either positive or negative charge. Here the atom or group atom which lose this share pair electron always gain positive charge, and the atom which gain share pair electron towards it, that always gain negative charge. And in heterolytic bond fission there is formation of ion, and always ion contain even number of electron in its valence shell. Here 1 2 3 4 5 6 7 8 electron, because in HCl molecule in chlorine there is 3 lone pair electron, and this pair is also shifted towards chlorine, total 4 pair in this heterolytic bond fission, therefore here 8 electron. Okay, this is homolytic, heterolytic. Homolytic bond fission give free radical, heterolytic give ion. And now come to condition. And this homolytic heterolytic bond fission, where homolytic bond fission takes place, when we carry out reaction at high temperature, there is homolytic fission, and when we use electricity as a catalyst in chemical reaction, there is homolytic bond fission, and when we use light or UV or sunlight, there is homolytic bond fission, or in presence of peroxide, organic peroxide, there is homolytic bond fission. Similarly, non-polar substrate, suppose when we take NaCl molecule, this is ionic, therefore there is always heterolytic bond fission. But when we take carbon hydrogen bond, this is covalent, non-polar, therefore there is always homolytic bond fission. In non-polar solvent there is non-polar substrate, there is homolytic fission. Non-polar solvents, non-polar means organic solvents like CCl4, CS2, in presence of these solvents there is also homolytic bond fission. And now come to condition of heterolytic bond fission, polar nature of bond. Here in NaCl molecule, in between sodium and chlorine, there is ionic or a polar nature of bond, therefore in NaCl molecule there is always heterolytic bond fission. And similarly, polar solvent, suppose when we take water molecule H2O, this water molecule ionized to give H plus OH minus, therefore it is ionic solvent, and presence of ionic solvents like water HCOOH, there is always heterolytic bond fission. Similarly, when we carry out reaction at room temperature or low temperature, there is also heterolytic bond fission. And this is the homolytic and heterolytic bond fission. And next there is reaction intermediate. Detailedly I will discuss in next chapter. And in reaction intermediate there is carbon free radical. In organic chemistry, carbon free radical, carbocation, carbanion, carbene and nitrogen. And suppose when we take here CH3CH3, suppose ethane molecule, and if carbon hydrogen bond is dissociated here by homolytic bond fission, then this share pair electron in between carbon, one electron shift towards hydrogen and one electron shift towards carbon, and all in homolytic fission there is always formation of chargeless species. Here at the valence shell, hydrogen contain 1 electron, carbon contain how many electron? These 3 bond pair, 1 2 3 bond pair and 1 lone pair, total 1 2 3 4 5 6 7 electron, even odd number of electron and chargeless. And if carbon contain even number of odd number of electron in its valence shell and chargeless, this is called carbon free radical. This is hydrogen free radical and this is carbon free radical, and homolytic bond fission also give carbon free radical. And next come to how carbocation, carbanion are formed. And when we take carbon chlorine bond, and if we carry out heterolytic bond fission, this share pair electron shift towards chlorine, because here chlorine have high electronegativity value, this chlorine have 3 electronegativity value, carbon 2.5, and this share pair electron shift towards chlorine, and this chlorine gain negative charge, carbon gain positive charge, and carbon atom, and which type of carbon atom? having 3 covalent bond, here 1 2 3 covalent bond, trivalent carbon atom containing positive charge, this is called carbocation. And in heterolytic bond fission there is formation of carbocation. Similarly, when we take carbon metal bond, metal are less electronegative or electropositive, and metal always try to lose electron and always form cation. Therefore, this sodium lose this both CR pair electron, and in the bond fission there is this CR pair electron shift towards carbon and metal form cation. And here carbon contain 1 2 3 in 3 covalent bond, there is 3 pair electron, and this CR pair electron also shift towards carbon, and this carbon gain here CR pair electron, therefore it gain negative charge, metal positive charge. And when here this is called carbanion, and this heterolytic bond fission all give carbocation as well as carbanion. And what is carbanion? Trivalent. This is also trivalent carbon atom having negative charge and 1 pair electron and 3 bond pair, 1 lone pair electron in its valence shell is called carbanion. That is negative charge in carbon atom, this is carbanion. And now see here what is carbene and nitrene. Here carbene and nitrene, these are also reaction intermediates, and suppose here only one bond fission is takes place, but here if this carbon contain 2 chlorine and simultaneously when this both bonds dissociation takes place, then here suppose homolytic bond fission takes place, then 2 chlorine atom dissociate from here to give chlorine, because in homolytic bond fission there is formation of chlorine free radical, here chlorine free radical, and 2 chlorine free radical combine to give chlorine molecule, and here carbon contain 1 hydrogen 1 alkyl group, and from homolytic fission of 2 covalent bond carbon gain 2 electron, and the here carbon atom having 2 covalent bond or divalent carbon atom with 1 lone pair electron and chargeless, this is called carbene. And there are 2 type of carbene, singlet, triplet, and this is I will discuss in next video. And similarly, what is nitrogen? Simply look at here what is nitrogen. And nitrogen always contain 3 covalent bond. Suppose here it contain R, this is alkyl group, X, Y, there is another 2 groups. If here also homolytic bond fission if takes place in between nitrogen X and nitrogen Y group, then XY combine to give X and Y combine to give XY. And in the nitrogen, in the dissociation of 2 covalent bond, if there is homolytic bond fission takes place, then here nitrogen gain 1 pair electron, and already here nitrogen contain 1 lone pair, means here monovalent nitrogen atom having 2 lone pair in its valence shell are called nitrogen.